In this illustration, we'll analyze the interference by reflection from two plane mirrors. Here the figure shows an optical system in which S is a source of light of wavelength lambda, and on a screen interference pattern is obtained by light interference from the reflected light from these two mirrors. That is saying, if point P on a screen, which is shown here normal to a screen in front of the source, the first maxima of interference pattern is obtained. We are required to find the value of lambda. We are also given that d very greater compared to small d, which is also high compared to lambda. So in this situation, we can analyze the given setup as a similar setup of YDSE. Here we can see if these are the two mirrors and source is located at a distance d from one mirror and 3d from other mirror, then the two images are obtained for the source. One is S1 at a distance d from first mirror and another at a distance of 3d from the second mirror, this is S2. And this is the location of a screen. And if we talk about the separation between the two sources, here we can see the total separation between the sources will be 3D, 3D, D and D. This is 8D. So the midpoint or the central line would be somewhere here at a distance 4D from one source. So this distance is D. And this point can be taken as the center of a screen where path difference due to light coming from S1, S2, which is the light reflected from the two mirrors, will reach at point O in zero path difference, or this point will be taken as a central maxima. Now we are given that in front of the source, the point P is taken as first maxima. That means here path difference would be lambda, and say this is located at a distance x from O. And we know well for a setup similar to YDSE, path difference at point P is for the two waves reaching from sources S1 and S2, whereas actually light is not coming from S1 and S2. These are coming after reflection from these mirrors, and we are assuming the size of mirror is significant so that after reflection light will reach at different points on a screen. So here we can write the path difference as a small dx by capital D, whereas the small d and capital D for YDSE, if we correlate here, small d here will be replaced at 8d and x will replace by, if this is d, and this distance would be 2d. So x will be replaced by 2d divided by capital D. And this path difference should be equals to lambda, because this is the first maxima from a screen center. Now in this situation, the value of lambda we are getting is 16d square by capital D. That is the result of this problem.